Okay, so we're going to start off with some of the quick proofs of these double angle formulas that are listed up top. So how do they get like that? Okay, and so what we're going to do is that in order to prove the first one, which is sine 2 theta equals 2 sine theta cosine theta, we are going to take the original sum formula for sine, which looks like this. And what we're going to do is something kind of clever here, is that we are going to, since we're adding two angles together, and I can go ahead and say that, is it fair that I can write 2 theta, that would equal theta plus theta, so two of the exact same angles. So what I'm going to do is that I'm going to drop in thetas for alpha and beta, like that. And then I'm going to go ahead and drop them in to the right-hand side of the formula. And now it's just kind of a matter of collecting like terms. So let's see what we got. And when I say collect like terms, let's check this out. So I know that theta plus theta is going to give me 2 theta. So I'd have sine of 2 theta equals, and now I got two of these guys. Sine theta, cosine theta, sine theta, cosine theta. So it's fair to say that I have 2 sine thetas, cosine thetas. And it looks like that completes the formula up top. Okay. So what I want you guys to do is take a shot at proving this second one here using the cosine sum formula. Okay. That is back here. So this guy right here. So you start there and see if you can prove it out. So give it a pause and then see if you can see the solution or find your way to the solution. All right, there we go. Using the same technique, we have derived it out using just basically dropping in the double thetas for alpha and beta there, and using algebra from there on out to prove it out. So on to the tangent one, which is a little bit more burly and is going to need some more setting up. So let's take a look at it. Okay, so this tangent guy here, what we're going to do is that we're going to rewrite tangent on the left-hand side, because that is going to look like this. Okay, so we're going to have sine of 2 theta divided by cosine of 2 theta, like that. And I'm going to just be working this side, the left-hand side, to get it to look like the right-hand side. Okay, just to save some room here. And so what we're going to do is that we're going to take the definitions from up top and stack them on top of one another. Okay, like that. Now, when I can't remember what to do with this this particular proof, what I do is that I kind of try and say, okay, well, I look at parts that are really kind of telltale. Like this one is in the same position as this cosine squared here. So how do I get a cosine squared to look like a 1? Well, can I divide or multiply the top and the bottom by 1 over cosine squared? So let's do that. Okay, so we're going to multiply the top and the bottom by this. So I'm going to distribute this into each one of these and rewrite it down below. Okay, so with this all distributed in, we can see how this might fall apart a little bit. Okay, so let's kind of take a look at the denominator first. We get cosine squared divided by cosine squared, which is 1, which is good because it takes care of that guy. We got sine squared over cosine squared, which is going to give us tangent, okay, over here, tangent squared, theta, which is over here. We can take one of these cosines and cancel out with one of those cosines, and that's going to leave us with another sine over cosine, which is tangent again, which takes care of that, and there's the 2. So at the end of the day, what's left is that we got 2 tangent theta all over 1 minus tangent squared theta. Okay, And so, yeah, that one is, due to this step right here, is not as intuitive as the other ones. But still, this is the form in which most folks, this guy right here, most textbooks and whatnot, recognize as the best way to state the formula here. Okay, so that's what the double angles, where they come from. And so let's take a look at some of the uses for these guys. Okay, so here's one that's going to give us a little bit of an exercise in all of the formulas here. It says, use the following to find the sine of 2 theta, cosine 2 theta, and tangent 2 theta. And then we have, as in previous videos, some information that's given to us. So let's go ahead and draw out a triangle the same way that we did. Okay, and it looks like it says it's in between 3 pi over 2 and 2 pi, so that's going to be fourth quadrant over here. And I'm just going to draw this dummy triangle here, which is more of a placeholder. And it says the cosine, and this is going to be 5, the adjacent over the hypotenuse here. And so using the Pythagorean theorem, I believe we're going to get x is, or the missing side is 12. And so I'm just using a lot of Pythagorean triplets here for ease of instruction. All right, so let's go ahead and tackle the sine of 2 theta first. Okay, so the sine of 2 theta, let's write out the formula. Okay, and I should also note what I left off my picture here is this theta. And so we can write off to the side, since it looks like we're going to be using sine, cosine, and tangent. Let's write the values based on the triangle here, just in purple, so we can just go back and grab them each time, because we're going to be using these. So the sine is going to be 12 over 13, but it's in the fourth quadrant, so it's a negative 12 over 13. Okay, cosine, which is given to us, so the cosine of theta is a positive 5 over 13, and the tangent of the theta is going to be, let's see, opposite over adjacent, but it is in cosineville, so it's going to be a negative 12 over 5. Okay, so what we can do is that we can just plug these values in and see where this takes us. So we got a 2 sine, which is going to give us a negative 12 over 13. And then we have cosine, which is 5 over 13. And so multiplying that out, at the end of the day, we get a very ugly number, a negative 120 over 169 here. Okay, so that is the value of that. So let's move on to, so this guy is done. Let's move on to this business of the cosine. So taking this out, let's write the formula. Okay, so throwing the values in, you can see why I wrote them off to the side, because we're going to keep using them over and over again. So we got 5 over 13 squared minus, it looks like we got the sine value here of a negative 12 over 13 squared. And so at the end of the day, putting this in our calculator, we get yet another yucky number. It is going to be a negative 119 over 169. Okay, and so let's tackle this last one, which is going to be the tangent. And so tangent, let's write the formula. Okay, and so looks like we're just dropping in some more values, all the tangent values, so let's do that. So I have equal sign 2 times tangent, which is going to be a negative 12 over 5. Okay, and we have all over 1 minus, let me write that, that's 1 minus, and a negative 12 over 5 squared. Okay, so after throwing that in the calculator, let's see what we get. Okay, so dropping that in the calculator, we are going to get a positive 120 over 119, which we're 3 for 3 on some yucky looking numbers here. So that's how you do that part using the double angle formulas. And yeah, I guess we're going to move on to our last part in the next video, which is doing some identities with these guys. So see you in the next video.